All right, so the triangle sum theorem is basically what we just proved, okay? So it says the sum of the measures, what does sum mean?
Addition.
Add them up. The measures of the interior angles of a triangle is, in other words, if you take these three corners and you tear them off and you put them in a row, what's going to happen? Straight line. So they should sum up to 180 degrees. Always, no matter what type of triangle it is. That is called our triangle sum theorem. Easy to remember. Sum, add up. Okay, that's what we just proved with our pieces of paper. So now we have another theorem. It's very similar. It's kind of like the activity we just did. And it's called our exterior angle theorem. What's the only angle on that picture that's on the exterior of the triangle? 1. Angle 1, right? So angle 1 is our exterior angle. And the measure of the exterior angle equals. Now, what if I took off A? What if I tore that off? And then I tore off B, and I put them over here? What would happen? It's going to be 180, right? So that measure of angle 1 is basically B and A summed together. So fill that in. The measure of angle B plus the measure of angle A. The fancy way of saying it, and you kind of need to know this vocabulary, says the measure of an exterior angle is the sum of the measures of the two, fill this in, non-adjacent angles. What do I mean by non-adjacent? They're not touching, right? So, for example, angle 1 is touching this angle right here, right? We would call those adjacent. However, the two we want to tear off are A and B. So the two angles that are not touching angle 1 would fit right into that slot. So they're equal. Okay? Any questions on that? All right. So let's do a couple examples here. It says, find the missing interior angles using the triangle sum theorem. Okay? So take a second on your own and try and figure out the missing interior angle on this left triangle. Basically, how many total degrees are there? 180. Minus, we're going to subtract the two angles that we know. So what two angles do we know? 90 and 45. So minus 90 minus 45 equals 45 degrees. So this angle would be 45 degrees. Yeah. How did you do it?
I just see where the square is. I just divided it in half between those two, and I knew that it was 90, so I knew that half of 90 was 45. So if you add the two 45s to 90 plus 90 is 100.
Yeah, good. We're going to learn the theorem. You kind of learned the theorem on your own real quick. So if this is 90, how much is left? 90. So these two will, if this is a right angle, these two will always be split between 90 degrees. All right, so who thinks they have an idea of how I can find this angle? Well, that's really our goal, because we have to find the other angle to find that one. So, Chloe, what do you think?
Oh, you have to do.
What's our first option?
Well,
Go ahead.
A plus B, you can take the outside angle and subtract the
Good. So she's using our exterior angles theorem, which says the two non-adjacent angles should add up to equal the exterior angle. So in other words, 23 plus what is 48? Do what?
25.
Yeah, 25, right? So this has to be 25.
Is there another way to do it?
Yep, you can do it another way. So what do we know about these two angles?
Equal to 1?
Yeah, 180, right? So what would this angle right here be if it's in a linear pair with 48 degrees? Do what? 132. And then, if we kind of ignore the 48 now, what do we know about the three interior angles? Yeah, so then you could do 180 minus 132 minus 23 equals 25. So either way you do it, you'll get the same answer. Okay? Doesn't matter. Okay, we got a couple more theorems. So this one here is basically what Kaylee said just before lunch. If we know this is 90, how many degrees are left for A and B to share? 90, because 90 plus 90 is 180. So if this is a right triangle, that means A and B have to add up to 90, which means they are complementary. So basically that right angle is half the triangle, half of the degrees, 90 degrees, which leaves only 90 degrees for A and B to share. So if you take a look at our example down here, is this on your notes? This triangle right here?
No.
So if you just take a look at it here, if this is 90 and this is 30, what would be left for angle A? It would have to be 60. In other words, what is 60 plus 30? It should be 90. 90 and 90 makes 180. Okay, pretty easy. Moving on. Take a second, and I want you to see if you can set up an equation for this example. Okay, so set up an equation. Don't solve it yet. I just want you to set up an equation. And then what I'm going to have, or let me, real quick. Did anyone see 3x minus 9 equals 180? Did anyone see that happen?
No.
You saw it? Or did you? Is that what you had? Why is that not correct? Does this angle look like it's a straight line?
No.
No, that's not 180. Okay, I see that one a lot, so it's not just one person, it's just one that I've seen happen. Who has an idea of one that they think is right? It might be yours, it might be someone else's. You're like, oh yeah, that's probably right. Kaylee, what do you think?
73 plus 3x.
Equals 180?
I don't know.
What do we think about that?
Nope, you're missing the x. Okay.
Well, whatever this is, these would equal 180, right?
Sure.
Angle BCA. But we don't know what BCA is, and that's assuming that they're both 73. If it was 73, they would be 180. But these are not the same.
Hey, I meant to put the 73 plus x plus 3x.
So
That's what I saw
73,
on somebody's paper.
73 plus x equals.
No.
Plus
Plus the
plus
3x.
three
Okay,
x
I'm.
minus nine.
Someone finish it off.
Plus 3 plus
Chloe
Equals 3.
equals 3x minus 9. This is correct.
What the heck?
Yeah.
So I did 3x minus that equals 73 plus x plus
I knew it.
Which theorem was this? Of the pictures on your page, which theorem looks like this?
Straight in.
Nope, that's not even on your page.
exterior angle.
The exterior angle
Oh,
theorem.
you have to move it.
The exterior angles theorem. What that says is the two non-adjacent angles should add up to equal the exterior angle. So 73 plus x equals 3x minus 9. Good. So now we just do some pose. So I'm going to do a subtraction pose, get the x's together. So that gives me 2x. And then what do I do next?
Plus the 9.
Add the 9. So I'll do an addition pose, which gives me how much on the left side? 82. And then we do a division pose. Therefore, x is 41. But we need to be careful before we circle that. We need to go back to the original problem and see what is it really asking me. And it's asking me, what is the measure of angle DCB? So what is angle DCB labeled as? Vincent, what's DCB labeled as in the picture? 3x minus 9. So 3, I'm taking this right here, and then I'm going to plug in 41 for x minus 9. So 3 times 41 would be 123. Minus 9 is
114.
114.
114 degrees. The last theorem that we need to learn about today is our isosceles base angles theorem. Okay? And it's a pretty easy one. It says if this is an isosceles triangle, which means there's at least two sides congruent, then the base angles are congruent. If you had to take a guess, which do you think are the base angles of that isosceles triangle? Yeah, B and C. So we can put a couple arcs in here. We know that these would be the same measure. And the converse also happens to be true. And it says, if the base angles are congruent, then it must be an isosceles triangle, and those sides would be congruent. So forward and backwards, the regular statement and the converse are both true. So that means segment AB would be congruent to segment AC. Lexi?
Okay, I have two things. On the 4.7 theorem, do we have to know like the base angles theorem?
Maybe.
Because it's cut out on the
Oh, that's okay. Just write it down.
paper.
And then, be careful, I do want to warn you, the base does not necessarily mean the bottom, right? So sometimes an isosceles triangle might be on its side like this. So if I give you A, B, and C, which ones are the base angles? Yeah, B and C. It's the two angles attached, or the bottom of the two congruent sides. So it's not A and C necessarily. It's not the bottom. It's just whichever angles are attached to the two congruent sides.
Cool.
All right, so let's take a look at a couple of these. It says find the missing interior angles. So we need to find both of these. Ideas?
60. Just kidding. No.
What should we always start with? How many degrees? 180. That's what a triangle should add up to. And then which angle do I know?
30.
So I'm going to subtract 30.
7.
So how much do we have right now? 180 minus 30.
150.
150. So somehow we have 150 degrees left to distribute to the other two angles. But what do we know? If this is an isosceles triangle, what do we know about these two angles? They're going to be the same measure. So what should we do to 150? Divide it exactly in half. So they would both be 75 degrees.
Wait, so they always equal to each other?
Yep, if it's an isosceles triangle.
That's so cool.
Oh my gosh, I know, right? And then the last one is a little bit easier. If the base angles are, so this is the converse. If the base angles are congruent, what else is congruent?
Segment.
The two sides. So what are the two longer sides? This one and this one. So what would A be?
25. Oh,
8.
It would be 8 inches. And then, once again, we take 180 and we subtract the angles that we know. So minus 65 minus 65.
50.
So that is 180 minus 130, right? 65 minus 65. Or those add up. So 180 minus 130 is 50 degrees. So the measure of angle B would be 50 degrees. So you can kind of navigate your way around based on what they give you. Sometimes they give you one angle, but they tell you it's isosceles, so you can find the other two. Sometimes they give you the two angles, so therefore you know it's isosceles, and you can find the third. Done in both ways.